Good morning, everyone. Good morning in this sunny morning, at least in Brussels, and welcome to our event, Unleashing the Value of Smart Charging in Buildings, organized by smartEn in partnership with Power to Drive. We are quite happy of the good number of registration. We have more than 200 registered participants, and I'm really happy to welcome you all in these events. I hope it's going to be insightful and interesting for you all. I'm Michael Villa. I'm the Executive Director of smartEn, the European business organization integrating the consumer-driven solution of the clean energy transition. For us, climate neutrality is a must. And we have 3 additional and recent reasons that convince us further on the need to even accelerate the pace of the clean energy transition. First, the extreme weather conditions that affected our continent in the last months. Second, the alarming IPCC report issued in early August 2021. And third, the electricity price hikes in Europe, which are driven primarily by very high global gas prices and made evident to everyone the implication of having Europe still dependent for over 20% on gas-fired power stations to produce its own electricity. So climate neutrality requires a digitally enabled sectoral integration between transport and buildings through clean electricity. What does it mean? Well, in the short to medium term, of all electricity used for charging, about 20% will be consumed from charging at public sites in and between cities, while 80% will be consumed through charging in buildings, at home or at work, where normal power charging station points will be enough. The clean energy transition should therefore transform vehicles from mere transport assets to decentralized energy resources that interact with the smart buildings where they are recharging themselves, and together, buildings and transport support a more variable energy system. In fact, flexible vehicles and smart buildings can help integrate an increasing amount of variable renewable energy, increase system efficiency, and empower consumers to participate in the energy system in an active way. This systemic approach should be promoted through legislation at European level. Why? Well, charging an electric vehicles to drive a daily distance of 40 kilometers would increase by 80% the daily energy demand of average EU households. Negative lock-in effects are associated with the deployment of non-smart chargers, both for the system and for the consumer. We need European legislation to ensure dumb chargers are not installed in our buildings, only intelligent ones that enable unidirectional and bidirectional functionality. What are the benefits of this approach? Well, under the assumption that the energy market will fully reward flexibility by 2030, and the cost of smart charging will drop from the current 300 euros to a bit more than 100 euros in 2030, the European Commission itself, in its recent impasse assessment to support the Fit for 55 package in July, estimates that by 2030, every smart charging point can create, on average, a system benefit of more than 100 euro per year. An increase of smart charging from 30 to 70% by 2030 would lead to 1.2 billion euros annual savings in the overall systems. Figures, once again, from the European Commission in July. And with those chargers providing also bidirectional functionalities, those savings increase to 1.6 billion euros. This makes much more sense if you consider our smartEn estimation that in 2025, the marginal difference in investment cost between normal and smart charging would be less than 50 euros. So the revision of the Energy Performance of Building Directive is the opportunity to fill this gap and mandate the deployment of intelligent chargers in all buildings across Europe. As you can notice from the agenda of today's webinar, in this event, we are going to discuss with policymakers what can be done in regulatory terms, and also understand from business representatives that technologies are already available and indeed stress their benefits. So I'm really happy to start today's webinar by introducing Paula Pinho, the Director of DG Energy of the European Commission. And indeed, sorry, I forgot to give some housewarming rules in the previous slide. So indeed, questions can be submitted through the Q&A box that you see on the dashboard. So we want this webinar to be interactive, so don't hesitate to submit your questions. And also participants can react by indeed expressing their satisfaction or not to speaker's intervention by using the emoji function also on the dashboard. So voila, I'm giving back the floor to our keynote speaker, Paula Pinho, Director of DG Energy from the European Commission, which will open with a keynote speech, our event. And Paula, you have the floor. Thanks.
Thank you, Michael. Good morning, everyone. Also from Brussels. I hope you can hear me. Thank you for the invitation for this very, very timely event. As Michael already said, some of the key elements of this important subject, which is really the smart integration of transport and buildings in the clean energy system, and which is really key in delivering the European Green Deal, in delivering in the path towards climate neutrality by 2050. And in order to get there, what are really the regulatory, Michele, you mentioned the legislation, what are the regulatory, what are the enabling, and what are the funding tools that are being put in place to make this smart integration of transport and buildings in the overall energy system possible? As you know, the European Green Deal set the vision and then really the path for a modern and resource efficient competitive economy with no net emissions of greenhouse gases in 2050, and where the objective is really to decouple the economic growth from the use of resources. And it is in this context that switching to a low energy system really requires rethinking the entire energy system, from buildings to transport, from industry to power. So really all sectors need to contribute to this transition. And with the adoption of what was the first part of the Green Deal package, also called the Fit for 55 package, in July, and with the planned adoption of the remaining parts by the end of the year, we are really taking big steps in terms of setting the regulatory conditions towards the smart integration of transports and buildings in the energy system. So let us start really going into what are the aspects, the elements of this regulatory framework, of the proposals, the legal proposals which have been put in place and which are coming up. So from July, it was essentially the revised Renewables Energy Directive, as well as the regulation for the alternative fuels infrastructure. You know it from before as a directive. Now it is being proposed as a regulation, so directly applicable in the member states. And still missing, coming up towards the end of the year, is the revision of the Energy Performance of Buildings Directive. All three legal proposals are relevant for smart charging. Looking into the regulation for the alternative fuels infrastructure, there it's really about setting and the adequate refueling infrastructure that we need to enable low and zero emission mobility solutions. And that's why in this proposal we are setting ambitious targets on infrastructure, which are targeting both light and heavy duty transport in different transport modes. And the idea here is not only to ensure a big deployment in refueling points across the EU, but also to make them more user-friendly and very, very important, to strengthen the interoperability. It is important that all these refueling points can speak to each other. So interoperability is key, both in terms of the physical standards, but also in terms of the communication standards. And the price transparency and the possibility to have common payment methods at all recharging points is equally important. So these are elements set out in the now new abbreviation AFIR, the Alternative Fuels Infrastructure Regulation. The idea being, of course, that where possible, transport should be electrified and take up the increasing levels of renewable electricity. Then we have the proposal for the revision of the Renewables Directive. And it also includes new incentives for electric vehicles, starting with a credit mechanism for the contribution of renewable electricity, the availability of real-time information on the penetration of renewable electricity in the system, a requirement that low-power chargers have smart charging functionalities, and requirements for access to battery data. So these are elements now proposed in the revision of the renewables. Finally, as indicated, we are still working on the revision of the European Performance of Buildings Directive, planned for the end of the year. And here we're looking into the possibilities of strengthening the already existing provisions for e-mobility, complementing what has been proposed in July, and looking in particular at the removal of administrative and other barriers which are preventing citizens from actually having access to e-mobility infrastructure, and looking also at the potential of the potential need to upgrade the existing obligations in view, of course, also of the new and more ambitious climate target. All of this is taking place in parallel to the ongoing check of the national transposition measures, which we cannot overlook, which have been put in place already in the existing Performance of Buildings Directive, and where there are already e-mobility requirements, and we are assessing to what extent and how member states have transposed these provisions into national legislation. Now, this in terms of what are the regulatory elements. Now, in terms of the enabling conditions, smart charging is really a biggest opportunity we have to provide flexibility services to the grid. And it is mainly possible as slow charging. It is happening mostly in buildings, both residential and office buildings, and within individual homes. And whether this flexibility will be offered by mobility service providers, by independent aggregators, through existing building management systems, or most likely a combination of all, of course, will be seen in the coming years, and will be interesting also to hear how you are going about it. One thing is clear: for this flexibility to be a reality which is upscalable, we need to create an interoperable ecosystem where smart meters, smart charging stations, and energy management systems are able to interact. So again, I cannot emphasize enough the importance of interoperability. We are now finalizing the competitiveness progress report, which is due for the adoption end of October, and where you will see that electric vehicle charging infrastructure and platforms are expected to really go through a boom in the EU during this decade, with combined markets expected to grow from current 0.63 billion in 2020 to 6.7 billion by 2030. Now, with this booming electric vehicle market, big opportunities will be created both for the home energy management systems, but also for the building energy management systems, as it becomes really one of the most important electric loads that could be shifted flexibly in the homes and in the buildings. So still on the enablers. So first came the smart meters. Clearly, this was important enabler, the broad deployment of smart meters. It was pushed by an early regulatory framework, which led to a growing EU market for smart meters, mostly supplied by EU producers, which is good news, at least when it comes to hardware. And then followed the smart services. This is really now the second phase of the smart meter deployment, is really where we will be focusing on the smart services which are offered to the consumers. And here, in between these, we now also have to look, of course, into the differences between new buildings and existing buildings. And it is clear that whilst the European requirements for chargers in new buildings are evolving towards electric vehicle charging integration by design, main and major challenges still exist concerning how to go about its most effective implementation of charging solutions in existing buildings. So, of course, in all this deployment, we need we do face challenges which we need to overcome. So this, in terms of setting out just some of it, but then finally, so we had the enablers, we had the legislation. Funding is the other element of the cake that we need to put into place in order to make this smart charging a reality. Now, the EU is funding different partnerships through the Build for Europe, the CTP, various missions and research calls under the Horizon, where we're looking into interoperable solutions for flexibility services using distributed energy storage, where we're looking into the achievement of optimized electric vehicle charging and vehicle to grid flexibility and others. So clearly, with this combination of regulatory, enabling funding tools, we are really pushing and boosting the transformation of buildings and transport, which is needed to deliver on the European Green Deal. But all of these tools need you to really turn smart integration of buildings and transport into a reality. So time for the live demonstrations to showcase what are the available smart charging solutions, both in residential and commercial buildings. I look forward to also seeing those, and wish you a very interesting and funny in the sense of discoveries this morning, and seeing what is out there already in terms of live demonstrations of smart charging. Thank you very much.
Thanks a lot, Paula, for your reassuring and motivating speech. I really appreciated the need to indeed focus also on the renovation of buildings with regard to the charging. Your clear statements on the interoperability within the transport sector, but between also the transport sector and buildings, and also your call to upscale the flexibility from the demand side. Thanks a lot for your intervention. We will indeed, Paula needs to leave today, but of course we will be in touch in the next month with you and your services in view of this forthcoming revision of the Energy Performance Directive. Thanks a lot, Paula. And now I'm glad to give the floor to Zach, who is going to moderate the second part and third part of today's conference. Zach, you have the floor.
Wonderful. Thanks a lot, Michael. Yes, my name is Zach, or Zackes Brustig in German. Dialing in from Berlin, by the way. Unfortunately, Michael, the weather here is not as beautiful as in Brussels, but I'm nevertheless very happy to be here on board. I am here for Power to Drive, so the international exhibition for charging infrastructure and e-mobility, which, by the way, is taking place in October. So it's really an honor to be part of this setting today, because this is really the topic we're very passionate for. Paula already mentioned the interoperability, which is key, and that's something I'm very much looking forward to also directed our panel discussion later on in around about half an hour, because we'll have some really interesting business stakeholders here on board for a short panel discussion to make sure we'll discuss that. But before we get there, of course, we want to have some live demonstrations. Paula already outlined all the regulations that are necessary to really have that market grow, to build that infrastructure, and to put all this very promising technology into reality. But of course, there are some real world cases out there already, which are working now already. They're installed in cars, they're installed in buildings. May it be V1B or V2B, so smart charging, or even bidirectional charging. And that's exactly what we'll have a look at now. And we'll kind of make a tour through Europe. So we've already been in Brussels, now we're in Berlin. And we'll actually have a look to Denmark, France, and also to Munich with our next three speakers. And they'll all give us actually a live tour right out there in the field. We'll have a look at actual buildings and cars. So it's going to be technically challenging in the camera sense, but it's going to be very interesting. Let me introduce you the three people and experts taking us on a tour now. On the one hand, we have Eric Mevelec. He's working for Dreev, so he's the CEO of France for Dreev, and Dreev is part of the EDF group. Next up will be then Xavier Moreau of Nuvve. He's a strategic advisor for Nuvve, specifically for Europe. He'll actually take us to Denmark. And last but not least, we have Raphael Hollinger dialing in from Germany, Munich, on behalf of the Mobility House, where he's the director for vehicle-to-grid integration. Well, having said that, let's not wait any longer. And let's start with our look and to what's happening in France and what's literally on the street and in the buildings there already. Off you go. Welcome, Eric.
Hi, everybody. Very pleased to be here with you today and to start this quite unusual live demo. So I'm very honored to start for the next 7 to 8 minutes. I'm currently in the basement of Dreev office, so it's in France, near Paris. As you mentioned, Dreev is a joint venture between EDF and Nuvve. Probably you know both this company. EDF is a well-known company in Europe, and Nuvve is well-known for V2G as well. And I'm going to show you some V2G capabilities. So we have here in our basement a Nissan Leaf that is currently plugged on one of our charging stations, like you can see over here. And this is a live demo. Basically, this charging station is running on a production environment among a bit more than 100 others of this kind, mainly in France, a bit in the UK, and some over Europe. So we've been deploying this charging station for almost a year now. Well, so let's start the demonstration. So if you look at the charging station, you can see that, yes, it's a charging station. It's blue from a user point of view. That just means that everything is going well. I have plugged my car. Everything seems to be fine. It's under what we call a transaction, so everything is working properly. But now let's have a look, I would say, behind the scene. What is really going on, and what are the exchanges between this vehicle and the electrical system and the grid. So I'm launching just a tool, and so it's a bit technical, but you will see here some graphic, and here you have the power, the power, and currently it's discharging in the network. It's discharging a bit more than 10 kilowatt. From a user point of view, we don't know that, but this is what is going behind the scenes. So why do we do that? Why are we discharging the vehicle? Well, for multiple purposes, we can do spot optimization, frequency regulation. We will have a look at this just after, and we can stack different services that can generate value to be shared with the customer and the owner of the EVs. But I'm not going to spend much time about the economics. I think my colleagues are going to talk about it. What I would like to talk with you is about decarbonation, because this is something we are really working on, and we believe we can mix positive business model and decarbonation services. So for the purpose of the demonstration, let's imagine that indeed we are in a moment in which we need to help to decarbonize, and this is why we provide currently energy to the grid, as I was saying. So that's fine. Here I'm fully discharging the vehicle into the grid. But let's forget at the moment that we are talking about grid and renewable. As a driver, as an EV user, I just want a car and I want to use it quite simply. So what's going on from a user experience point of view? Well, it just says that my car is, I hope you can see that, is 68% charge. This is the state of charge. And if I look at my mobile application, you would say, okay, I just want to be fulfilled at 70%. So it's a bit more than 200 kilometers between 5 and 7 p.m. So this is what we call mobility needs. As a driver, my need is to be ready to take the car at this moment. But let's say that today there is something unusual, and I want to take my car, I don't know, in half an hour, fully charged. Well, that's not an issue. I can just say I want to charge immediately, and you have seen on the mobile app and on the charging station as well, the color has changed. And if we go back now to my computer, you will see that we start to charge, fully charged. So we were discharging, we were providing services for the grid as a way to decarbonate electricity in Europe, to insert renewable, for example, and because my car is my car and I want to use it for lunch or whatever, I have just decided to charge it, and I keep the hand over that. And this is very important for us, because we don't want to forget that an EV is not a battery on wheel. It's an EV, and our customers, so mainly fleets today, but the economics are the same for B2C customer. They could definitely have this technology in a few months or years, once we have solved all the, I would say, interoperability and technical issues that remain. But the idea is really to forget the technology and let the EV be an EV for the driver. Mobility needs are very, very important, and I'm just going to show you. I'm going to show you, what's going on a site. So you can see here we are providing frequency regulation. So we are contributing at the moment. We are charging and discharging following the frequency. So this is something we can perform with V2G, and it's very nice to generate revenues. But at the moment, we need to charge, because we need to give back the vehicle fully charged to the customer. So this is what we ensure at any time. So as a conclusion of this demonstration, I would say that we have some key factor to enhance V2G capabilities. It's ready. I hope you enjoy the demo and you see that from a technical point of view, it's fully ready. From a user experience, it's very easy. It's a normal charging station. From a day-to-day perspective, you forget it. You don't have a specific stuff to do or any complexity to deal with. And it's very important that once again the EV remain an EV, and the mobility needs and all the constraints linked with the insertion of the EVs on a local point of view regarding the power of the site, etc., are completely managed. And then once we have well managed that, then we can stack multiple vehicles, stack multiple services, and work for the grid and share the value with the customer. So this is a great journey we have in front of us. I think interoperability was mentioned several times. This is something very key. Hopefully in Europe we were able to start with CHAdeMO, and now we are contributing to the evolution of the European standard, of course, CCS, and sharing data, being able to switch between cars, charging station, and contributing all over the value chain in Europe between car manufacturer, OEM, utility service provider is something that we are looking for in the next months and years. I hope you enjoy the show, and I let the mic to Xavier, I think, who is going to continue this presentation.
Yes, thanks a lot, Eric, for this great presentation. I can see that there are already some questions coming in for you, Eric. So yep. Luca and Alexander asked 2 questions. We'll just put them on hold for a little bit, and then once we're through also with Xavier and Raphael, we'll take enough time to answer this question with 3 of them right here. So thanks, Alexander and Luca, for sending some questions. Please continue that also throughout the next 2 presentations. Send us already all your questions so we're prepared for the Q&A and the afterwards. From Eric, we will switch over to Xavier in Denmark, and I'm very much looking forward to hear from him what kind of product they're working on, what they already installed there, and I can see he's already standing on the street. So let's go. Xavier, are you with us still? I could see you for a moment. Now you're gone. Here you are. Perfect.
Can you hear me?
Now we can hear and see you. The stage is yours.
Well, hello. I'm in Denmark. I'm at Frederiksberg Forsyning, a utility services company in Copenhagen. As you can see on their building, they have some solar panels, but some of their electricity for this building is also coming from a wind farm that they own outside of the city. So today, I'd like to show you the benefits of vehicle-to-grid to users, but also to society as a whole. I would like also to ask you to ensure Europe deploys a future-proof charging infrastructure. And finally, I will suggest some targets for vehicle grid integration. You can see next to this building 11 electric vehicles of the fleet of Frederiksberg Forsyning. These vehicles use the technology from Nuvve to act like storage, so to charge and to discharge their battery into the building. You can see these vehicles are used by the technicians of this utility services company for their daily duties. They run approximately 8 hours per day around Copenhagen. And the rest of the time they are parked. They are parked, but they are not idle. Because when they are parked, Nuvve is bidirectionally charging and discharging their batteries. They become a low-cost source of flexibility and storage to dampen the loads of the building, but also to flatten the generation profile from the solar rooftop PV. and to provide many services to the building, the network, and the whole Danish power system. So, for the drivers, Nuvve guarantees that at all times there will be enough energy in their battery for their daily duties. We also provide 24/7 monitoring and services to ensure they are always ready to perform. The vehicle-to-grid or V2G technology is invisible to drivers and to users because the Nuvve software platform performs everything in the background. So the only thing the driver has to do is to plug his vehicle when he parks. And then the platform takes over and will engage the dialogue between the vehicle and the charger to start the flow of energy. So pressing start, the charger will switch to vehicle-to-grid mode. You might have heard the sound of the charger coming online, and you see the flow of energy going into the vehicle. At every moment, the driver can be in control thanks to an app. It's possible for the driver to schedule his trip and set the charging level he needs for his daily duties. Also, should an unexpected trip come, the driver can trigger an emergency charge to have a very fast charge at any moment. So when the car is plugged into the charger, the power from the EVs can also be used in the building. As you see, it reverses the flow, and now we have energy flowing from the battery of this vehicle into the building to power, for example, the lights or the computers in the office. But this can work both ways. So when there is too much power coming from the rooftop PV or from the wind farm that belongs to Frederiksberg Forsyning, you can see the power being reversed and charging the vehicle to be stored in the vehicle, and later it will be fed back into the grid. These chargers and the batteries can also deliver very fast and precise response to the fluctuations in the grid. They can deliver the most demanding ancillary service, which is called frequency regulation. And frequency regulation is a very valuable service for the Danish operator Energinet. And Nuvve can generate a lot of value from providing this service. With each of these vehicles behind me, we generate over 1,800 euros per year and per vehicle. And this enables Nuvve to provide attractively priced charging infrastructure and also a low-cost charging. So this fleet has been operating commercially vehicle-to-grid for 5 years. Frederiksberg Forsyning has a greener fleet, has a lower cost of ownership for all its vehicles, and the Danish power system benefits from an additional source of flexibility to match the variable renewables available in Denmark. These flexibility resources have already been paid by mobility, by the need for mobility. So it's a real cheap source. So what is being done here with those 11 vehicles, but also with 5 other fleets totaling over 50 vehicles in Denmark, could be done all over Europe, aggregating a tiny portion of the batteries of millions of EVs to provide a virtual battery for the European power system. And for Europe to be a leader in renewables and electric vehicle integration, we need to scale up. And the more EVs will provide vehicle-to-grid, the cheaper the flexibility, and the more cheap flexibility, the more renewables you can have on the European power system. So to achieve this scale-up, we need first a level playing field for EVs to be considered just like any other distributed energy resource, with non-discriminatory interconnection rules, free access for aggregation to energy markets, and a fair taxation and tariff system. We also need a future-proof charging infrastructure with a vision and a plan to deploy it. Because imagine, if we deploy dumb chargers today, they will stay in the field for 10 to 15 years, just locking in the flexibility of these EVs into their battery. No one will be able to use it. By 2030, the huge majority of batteries being manufactured in Europe will end up inside cars. If they are locked in the cars useless, it will be a waste. And if we want millions of batteries to be useful, the revision of the Alternative Fuel Infrastructure Directive should go further. It's a step in the right direction, but it stops short of mandating bidirectional charging. The third thing we need is targets which are linking renewables and electric vehicle integration, because there's a synergy between EVs and renewables. With combined targets, we could have a greener mobility driving on renewable energy. We could avoid the curtailments, and we could have charging when renewable energy is abundant. So the technology is there, it's real, it's invisible to drivers. What we need now is mass deployment to scale up so that every European can benefit from the flexibility of its vehicle and monetize it with all this value from its car. Thank you.
Well, thanks to you. And it was really impressive to see that in the parking lot, you had all these vans already stacked up. So I can just imagine, if you scale that, what an interesting buffer that is also for the grid as such. So from you, Xavier, we come from Denmark to Germany, and we'll switch to Raphael Hollinger, presenting for the Mobility House. And by the way, you're really keen to ask questions. I love that, and we'll make sure to come to all of these questions. I think we'll actually have really more than 10 minutes because we're very good in timing. So to give a detailed answer to all your questions. So if you have more questions also to Raphael's presentation, please continue. Well, Raphael, are you in the line already? Let's just give him a minute to switch on the camera and the microphone.
Doesn't work.
So now we have audio, I think. We are still...
Yes, we do have audio, and we're still waiting for the video.
So camera access is not authorized. Please.
Oh, then I need to pass this on to Michael or Brieux. Can you authorize the camera access for Raphael?
It should be already authorized, Viviana and Raphael, as before. So maybe you needed to click on the third bottom at the bottom, and maybe click Update the Device Settings if you are experiencing some troubles. Is the star in the middle at the bottom of the screen?
Okay. Sorry, we do have issues. We will try to resolve it.
No problem. Maybe in the meantime, we can answer some of those questions already. So Xavier or Eric, if you can hear me and you're ready to switch on your camera again, we might be able to answer some of those questions in the meantime while Raphael is sorting out the technical issues.
Nicht, dass sie dich authorized haben, nicht mich.
Ah, yeah. Did you authorize the right camera? What is your name?
Viviana.
Viviana. So it's not Raphael, but Viviana.
Yes, we see you.
Okay.
We see you, and we have authorized your participation as Viviana.
I think you just probably need to select the proper camera or turn on the settings in Google. Yes, in the meanwhile, Eric, are you still with us? Or Xavier, are you still with us? Eric, here you are.
Yeah.
Perfect. I do have a couple of questions for you.
Yep.
Let me just quickly have a look in the chat. So one comes from Luca de Bruclier. I hope I pronounced it correctly. Thanks, Luca. And he asking, is the system working with any EV?
No, good question. So currently, we need the full technical solution to be bidirectional. That means the EV, the charging station, and all the services and the software. At this stage, only the CHAdeMO standard is capable of this technology. This is why we are all working in Europe over Nissan, Mitsubishi, and this kind of brand EVs. But it's moving. The what we call this version of the ISO 15118 is ready, and people are working on the stack. So we could assume that in I would say a year, 2 years, CCS bidirectional EVs will be ready. The charging station, of course, as well. So currently, we are on we are on a tiny market because we are only on CHAdeMO, and it's going to open very, very soon.
Wonderful. There are more questions, and I know a lot of questions came in also while Xavier was speaking. I know one is directly for you. It's a very specific question by Alexander Schuller. How will you implement V2G with CCS? And there you have to help me because it's a very specific regulation term. CHAdeMO will likely disappear in the medium term in Europe. Are you involved with the ISO 15118 developments?
Yeah, exactly. This is the point I was mentioning. So CHAdeMO has been deployed, and thanks to this deployment, we can make the proof and start the business over Europe. But indeed, if we want to make this technology a successful technology from a business point of view, we need to work on CCS. So CCS is the European standard for charging. Basically, all players around the table, all the players of the value chain are working on that. So once again, the EV needs to be capable of the charging station as well, and all the software. But all these guys are ready or almost. So let's say a year or two at maximum, and you'll see CCS bidirectional vehicle on the road.
Wonderful, Eric. Thanks for jumping in spontaneously. I can see now we have a live feed from Raphael. I muted you in the meantime, Raphael, so maybe you need to unmute your microphone again, unless you haven't. Just say hi, Raphael, so we know the sound is there. And yes, you need to unmute your microphone because I muted it earlier. Raphael, did you unmute the microphone, or can Brieux do that remotely? I'm afraid he can't hear me. So let's continue with another question. We have Xavier in standby to answer more questions. Xavier, let's have you jump in there. You also need to unmute your microphone, Xavier.
Okay, now we have audio and video, I think.
All right. So, dear audience, thanks for your patience there. It's 2 years of Corona pandemic, 2 years of testing all the systems that are out there, and it's still not working as we wanted. I think that's something everybody knows from their own home office and remote experience. But yes, Raphael, we're ready to go. So please take it away, and maybe aim at 7 minutes. Then we have a little bit more time for Q&A afterwards and can make up for the hiccups. Off you go.
Perfect. Thank you very much. And sorry also from our side for the technical issues. So where we are in Munich office of the Mobility House, more than 150 people working here on charging infrastructure, smart charging, and vehicle grid integration. In our garage, we have 12 parking lots with EV charging infrastructure, wall boxes from all different kind of vendors, and different technologies. So we have DC chargers, AC chargers, and also V2G chargers, all connected to our standard product, the Charge Pilot. The Charge Pilot is our product to manage fleets. That means that we are able to limit the power we need to ensure charging needs of our cars. In this case, we have 10 cars today charging here, and our Charge Pilot measures the load of this building. So we take the available power after, for example, using the elevators to charge the cars. We have a small video here on the screen where you can have a look how dynamically these things are working. So really every small increase in the building of power reduces the power that is available to charge the cars. Of course, always ensuring charging needs. Furthermore, in Germany, we do have already the regulation and the technology to react to the needs of the local grid operator. So whenever there is an emergency, you can reduce the power of our charging to, let's say, 50% of installed power, and our charge pilot will redistribute this reduced and limited power to the cars in an optimal way. Of course, within our own garage, we go one step further. So to the next level of our product, which is shown also here on this screen, where we see the intraday auction price curve. Today, we see prices between 90 and 300 euros. So it's really a good idea to charge in low price times with this increasing volatility we see in the short-term markets. And of course, by optimizing our charging, so using the flexibility of our electric cars, we can also help the electrical energy system a lot to increase the share of renewables and to decrease carbon emission by charging. And we, as the Mobility House, are operating batteries of electric cars since now, I think, more than 5 years in stationary batteries. So we are one of the biggest stationary battery operator in Europe, with batteries in France, Netherlands, and Germany, all equipped with batteries from electric vehicles, and really could develop a technology to optimally use this battery, so ensure a long lifetime, but at the same time make very good revenues by providing services to the local grid operators, to the TSOs, to the transmission grid operators, and also optimize all the flexibility until 5 minutes before physical delivery on the short-term markets. And this is the technological basis now for the next step we are approaching with this technology, where we bring this possibilities to the cars. Of course, today we are limited by regulation and partly technology or market available technology to V1G. So we do this usage of flexibility for mobile cars only in the V1G use case. But we also have V2G showcases and projects with many car manufacturers. Here we can see a Nissan Leaf on a V2G charger today, but we also have products and projects with Renault and Daimler, for example. That's all from my side. Thank you very much for your interest in the Mobility House, and I'm looking forward to your questions.
Wonderful. Thanks a lot. Yes, Raphael, I'm very happy we were able to make that work, and thanks a lot also for catching up some time. So let's have a look at the questions there. Please stay with us, Raphael, Eric, and Xavier. Please come back on screen so we can have a quick Q&A with the audience. I hope one of you guys can hear me while I pass on the question already. I know you need to switch back on your cameras. So let's give you a minute. Xavier is with us. Wonderful. Eric is back with us. So there are interesting questions. Here's one. How are consumers that is a difficult English word, remunerated for offering the services, capacity, energy-based? Are there penalties if you opt for emergency charging? Do consumers benefit from dynamic prices? I think that refers, for example, to the example of in my app, I can switch to, to just quickly charge my EV if I need it. Who wants to go first?
All right, can you go first?
Start off.
Can you hear me?
Yes, Eric, Xavier, maybe let's start. You start, and then we go back to Raphael.
That's fine.
So customers get a share of the value by having attractively priced charging infrastructure, and also they have some very cheap charging, almost free charging. It depends on the agreement. Here at Frederiksberg Fortuning, the agreement we have with our customer is that they get up to 20,000 kilometers of free charging. there is no penalty for emergency charging, because when we do the aggregation of all these EVs, we take into account the possibility that some will not be available for a short period of time, and we have enough to have some buffer in our aggregation pool.
Wonderful. So that's something you solve proactively without the customer actually noticing. Raphael, did you want to chime in on that question as well?
Yes, maybe just to add, I think what is important there is, of course, we need to let other stakeholders participate in this revenues we can generate by using the flexibility. For the V1G case, it's especially the customer we have to motivate. We have to motivate him to plug the car, to tell us when he will need the car again, and ideally also what's the SOC when he leaves, what is the minimum SOC, state of charge of the battery. And with this information, we optimally can use the battery of the car as flexibility option. And therefore, he needs to be motivated by participating in this revenues. For example, by collecting points for smart charging events, like other players already do it in the market today.
Raphael, I have a quick follow-up question there. You said the SOE, so that starting at charge, the status quo of the battery in regards to its charging. Mm-hmm. How do you get that information? Because that's something that car manufacturers usually are very secretive around.
So the state of charge, we have to differentiate state of charge and state of health. I think state of charge is something that is available within the car and the OEM APIs to the backends. Of course, the state of health is more tricky to get, but you can anticipate from the car when you have sufficient amount of information regarding charging behavior, etc.
Wonderful. Thank you.
Maybe to add on that, for V2G, of course, things are a bit more complex because you add stress on the battery also with the process of charging and discharging, or you might add stress and additional to driving. And then, of course, you also need close cooperation with the car manufacturer who have to allow you to use the battery. And that's why it's very important for us to be in close cooperations with the European OEMs.
Mm-hmm. I have a follow-up question there, but maybe I can get the answer from Eric or from Xavier, just to pass the ball around, so to speak. Eric, if you can unmute yourself. The question would relate to that as well. Is there any empirical evidence in terms of the effects on the battery aging or the loss in performance, because maybe car batteries are not specifically designed for the vehicle-to-grid aspect, or is that the case already?
Well, maybe some elements. So first of all, I think we all work with car manufacturers. So basically, when we provide this kind of service, we have agreement with car manufacturer, and we can maintain the warranty, and we can prevent any damages linked to ages of the battery. And so this is for the, I would say, customer-facing argument. But then when we look at the number, especially when we do services like primary reserve frequency regulation, this kind of services for the grid, from an energy point of view, it's not much. I would say it's a second order contribution to aging regarding mobility needs and normal driving. So, of course, this is something very important. And for me, the two important points are, the first one is working with the car manufacturer to be reassurant for the customer and to be sure that no matter what, the battery is still under warranty. Second stuff is, and this is what we do, we work closely with car manufacturer, and the pattern, the kind of cycle we do on the battery, we have some process to validate that with car manufacturer.
Thank you, Eric.
I'd like to add something.
Very quickly, because we still have a lot of questions.
On this fleet, we are closely monitoring the state of health of batteries. We've been operating V2G for 5 years, and we did not notice any significant degradation due to V2G. The degradation is much stronger from calendar aging and from the temperature here in Denmark, where it can be very cold in winter, and from the driving, accelerating when the traffic light goes green. But V2G is very small power and does not degrade the battery.
Oh, wow. I mean, that's impressive. So it's not only theoretical, so 5 years of experience on the street, that's quite something to source from. So interesting. So driving is much more a factor for aging of the battery as well as its time. And yeah, the connection to the grid is not as big of an effect as other factors. We're going to change the topic a little bit. Despina earlier asked, what is the cost for the driver to have V2G capability in his car? For example, what's the powertrain difference and what is the cost for infrastructure? Are V2G capable chargers more expensive? So what's the surplus? What's the extra charge for adding that capability? Who wants to go? Maybe Eric or Raphael?
I can go if you want.
Please.
Or Raphael, yeah.
Yes, Eric?
Yeah, so basically you have different kind of technology, but right now in Europe mainly people are working about DC charging. And in that case, the beauty of the model is that there is no overcost from an EV point of view. You have some overcost on the charging station, but it can be neutralized thanks to the revenue generated by the services. But from an EV point of view, it's mainly software adaptation. We were earlier speaking about the ISO 15118. This is just a piece of software to be updated on the EVs, and they will become capable of vehicle to grid. So that's the good news. Nothing special, I would say, on the EV side.
Wonderful. Thanks, Eric. Maybe the next question
I'd
then.
like to add something on that. So this is a regular EV, completely normal, and the cost of the chargers is going down very fast because the power electronics are improving. These are chargers from 5 years ago. You can see they are very big. They are almost as tall as I am. And if you look at Eric, and next to him there is a newer charger. It's 1/5 of the size of these chargers from 5 years ago. So you can see between these chargers and the chargers at Dreev, the difference in 5 years, the progress that has been made in power electronics.
Yeah, so an impressive innovation rate and also in terms of scale and size and costs. And I guess that's something where we will see even further developments just in the next 3 years. So it's going to be even smaller and batteries are going to be even more powerful and flexible. So we have a lot of questions. So just very quickly, Cirian wants to ask, in V2G, you're absorbing and injecting energy from/to the grid, FCR energy not being compensated. How do you cope with today's regulations and the huge discrepancy between feed-in and consumption tariffs? Who wants to go at it? Raphael?
Yes, perfect. So what we see in Germany is good conditions actually to operate batteries in the electrical energy systems. Unfortunately, it's limited to stationary batteries. So mobile batteries are not exempted when they are charged. They need to pay all levies, taxes, and fees, and they can charge back the energy, but they will not get back the levies, taxes, and fees. Therefore, in Germany, V2G really is impossible economically as of today with mobile batteries. But we can only practice with stationary in Germany. In other countries, that's different already. But I think that's the thing we are really striving towards, and what we need is a level playing field for flexibility options and not an exclusion of mobile batteries in this regards.
Thank you, Raphael. Last question, maybe. Luca wants to ask, do you think this cooperation with the OEMs will still be needed in the future? Or should a regular citizen worry about this instead of having this as a default service from EVs? So I guess the question is in the direction, will like the cooperations with OEM intensify? Is that something that's just going to be a all-inclusive package for the end consumer, so to say? Who wants to go?
Well,
maybe Raphael. Oh, yeah.
Please go ahead.
Yes.
So I think there's different options, and we will see how it develops. And there's from the service of having the car full service and everything is settled around. We will also see on the other side people who want to own their own car, own infrastructure, and choose when they are charged and when they are not charged. So I think there will be a variety of options, but we see more and more one-stop shop solutions. And of course, we are also striving in this direction to fulfill this customer needs.
All right. In regards to our time, we already reached the end. I know there's a couple of more questions. So my suggestion would be that I pass this on to Michael and Dreev of smartEn, and they maybe get back to you directly and make sure that you get some answers by our three excellent speakers. And we just handle that via email, if that's all right with you, Tomoko or Luca. So thanks a lot. To Eric, Xavier, and Raphael for dialing in and for really making this virtual tour possible, which was technically challenging. And I think thanks a lot for really throwing yourself in there and giving us this live feed on the street to your solutions. May it be even in the garage or out there in the parking lot. So that was excellent. Thanks a lot to the three of you.
Thank you very much. Bye-bye.
Thank you. Bye.
So that closes off our virtual tour and live demonstration. As you can see, those solutions are out there already. They're not theoretical. And I think it was really excellent to hear, for example, from Xavier that some of these solutions have been really tested for 5 years now with larger fleets. So there's quite a lot of experience to source from in regards to durability and practicability. And also it's interesting to hear that it's such a dynamic market that just within the next 3 years, we're going to reach a completely different status quo in regards to the size and flexibility of the systems. That brings us to our panel discussion. As I promised earlier, I'm going to make sure to answer one of the questions that Paula also put out there and many more. And we will have a next round of speakers, all coming from the industry. So it's an industry panel, and we're just going to talk to some of the industry stakeholders from large corporations to small startups. What their take is currently, what do we need to get further, and how can we get closer to the overall goal to unlock really the flexibility potential of electric vehicles and buildings within the next 9 years that are left until 2030. So who do we have for this talk? We have Stéphane Maravel of Schneider Electric. He's the global head of strategy for Schneider Electric, with a specific focus on marketing and new business development for e-mobility. We have Cyril Brisson. He's from Eaton Electrical, and he's the Vice President Sales and Marketing specifically for the EMEA region. We have Abraham van der Waal, Chief Product Officer of Net2Grid, bringing in a little bit like the startup angle, if I might say so. And we have Björn Utgard, who's the Vice President Sales at EVBox. Let's just make a quick welcome to everybody so we know the line is still standing and we can hear you. So just quickly, hello, Stéphane.
Hello, everyone. So I'm Stéphane. So
wonderful. That works. Welcome, Cyril.
Hello, can you hear me?
Yes, we can hear you perfectly. And we have Bram and Björn. And the way we're going to do it actually is that I'm going to ask each of you to give a 2-minute pitch, and just to quickly let us know what exactly you're working on with your company at the moment. And then we're going to dive into the panel discussion. So that's the pitch is going to be also a sound check then for Bram and Björn. Let's go back to you, Cyril. Maybe you can just give us a 2-minute pitch onto exactly where you're coming from and what your perspective is on this topic. And I have a short timer here running now. Let's go.
Yeah, so Eaton is quite a rare company because we are both in general electricity, building, and so on, and we are also in vehicles. So we have a long history of supplying vehicle OEMs with parts. So we are both in the electrification of the vehicle and of the infrastructure. And we've been looking at what happens when you deploy a lot of vehicle chargers and also storage, battery storage, and photovoltaic in buildings, and when you reach saturation point, and how you're going to change the infrastructure, the electrical infrastructure of the building, adding some intelligence, connecting all of this so that you manage all of those new loads and all of the new resources in order to meet the end customer's requirements. The end customers could be the building owner, it could be the building occupant, and at the end of the day, they are all going to have different requirements for their business and for their comfort, and adding all of these new load and new sources should be meeting those requirements at an affordable economic cost. So we are developing systems that are enabling you to multiply the power of chargers on the site, but doing so without blowing up your power bill, and doing so while still contributing to stabilize high renewable grids. So you could have grids that will have 60%, 70% renewables. They will need to have a lot of stabilization mechanism. And we think that the flexibility devices that you install on site, so all of those new loads and those new sources of energy, can contribute to stabilize a high power grid. So we are working on systems that will enable you not only to meet the requirements of the users, but to enable a zero carbon future by supporting a high renewable grid. So that's really the point that we are pushing in Eaton. That's why we call everything as a grid. It's because you're going to have flexibility, generation, and flexible load everywhere tomorrow. And this is what we have to manage with a lot of connectivity and intelligence. We can't hear you. I think you're on mute.
That was my bad while handling the timer. Perfect timing. Thanks a lot, Cyril. Splendidly hit those 2 minutes on the mark. So let's come back to you, Stefan. Also 2 minutes for you. And let's hear what exactly you're focusing on, what your perspective in this panel is.
Yeah, so hi everyone. So I will rebound on what Cyril was saying. I think the name of the game is called system, right? In this integration of EV infrastructure in the existing electrical distribution, and in particular in buildings. So we all know that now it's a fact, so it's coming, it's there. So and we'll have to cope with that, and we know that putting an EV infrastructure into a building can raise the electric consumption up to 40%. So we're going to publish, by the way, in the coming weeks, a white paper specifically dealing about that. And you will see all the numbers, and the studies are really demonstrating that. So then the challenge we are facing with this is really to make sure that we are able to increase this the load in buildings with the current electrical installation. We cannot do everything new. So that we need to also make sure that we are not stressing the grid too much with peak demand, and of course all this while keeping the cost under control. So this is where today we are working, and we have the complete holistic approach, looking at the full system. So Schneider is doing today a lot on the system approach, integrating all what we have, right? Schneider is a company that is from the electrical distribution, EV infrastructure, microgrid, building management system, operation software. So all this is being integrated into a system that will then enable this additional load coming from the EV infrastructure to be integrated into the full energy management system of the buildings. And doing that, we are really demonstrating that we can have this new infrastructure inserted into the building while keeping the costs under control, avoiding to upgrade all the systems.
Wonderful, perfectly timed as well. Thanks so much, Stefan. I'll pass on now to Bram van der Waal of Net2Grid. Welcome, Bram. Hope you're ready to ready and set as well. Let me just reset my timer, but I think you can start already.
Sure. Good morning, everybody. This is Bram from the Netherlands. You see this nice windmill in the background. This is how it used to be, and we are a startup, actually a scale-up right now that is focusing on energy data analytics. So that's our core activity, and we work together with energy retailers, mostly in the residential space, partnerships with charge pole manufacturers, but also recently we announced cooperation with a consumer bank. And why I mentioned these different segments and also different customers of ours is that our technology is based on energy load disaggregation, enables us to give insight behind the meter. So on residential side, we are able to disaggregate loads all the way to appliance levels, and we do this for smart meter data, for non-smart meter data, and also using real-time data. And the power of this data is that it gives energy insights on the end user perspective. It gives recommendations and also predictions on end user perspective, and on the other side for the energy retailers. The energy retailers for us are the main contact point towards the market, and they use our services to optimize their own offerings towards this market to help accelerate the energy transition. And what this basically means is that our technology allows the energy retailers to bring energy transparency to their users, to also their own internal optimizations of their operations, and really give an empowerment of the energy transition. And basically this means that the end users, the consumers and the prosumers in the market start trusting their energy supplier as a trusted advisor. And that's a unique position we currently have. So our technology is being integrated as a white label platform within energy retailers for energy insights measurements. We integrate with partnerships of EV charging operators, and also our products are being integrated within meters, so embedded software, enabling the smart meter as a really key component in that energy transition where our services are being offered from.
Thank you. Thanks a lot, Bram. Let's right away pass on to Björn and EVBox. Björn, are you ready to go?
I'm ready.
Please take it away.
Yeah, my name is Björn Utgård. I'm at EVBox now 4 years. EVBox started out about 10, 12 years ago. Our role is to manufacture charging stations and provide software that makes sure that those charging stations are always connected to the internet. We do so by delivering via car manufacturers. We deliver via electric utilities, distribution channels, and our focus is really to make sure that the first job of any charger is working well and that people are happy with that service. I think it's often we forget, and I've been sinful of this myself. We forget to think about the fundamental thing that the charger actually does, which is charge a vehicle, and everything else has to come on top of that. And that is both in terms of the technology, but also in terms of the services. What that means in practice is we are focused on how does an end user get a nice charging experience, and we're focused on how can we help car OEMs, electric utilities, the electrotechnical sector, how can we help them deliver good charging infrastructure and good charging experiences. If we look at the energy market, really, smart charging is about energy market integration of vehicles. The energy market is, of course, extremely complex across Europe. There's so many different regulations and so many different players and business models. We are very clear that it's not our role to be the end customer innovator on this. It's our role to provide the technology that allows companies, service providers that are closer to customers innovate. What that means in practice is that we always deliver charging stations that are connected to the cloud. We use OCPP open standards, but we also provide our own OCPP cloud with APIs that allows service providers that want to integrate and want to offer seamless end-to-end attractive services to innovate on our platform.
Thanks a lot, Bram. So that was a fast round.
Björn.
I'm sorry. Yes, Björn. My apologies. Thanks a lot, Björn. And that was a fast round of pitches and gave you a quick overview who's active in the market, who's driving innovations, a fast charging of who's who, so to say. We now want to take around 7 minutes for a couple of questions I have for the four of them. If you want to ask your questions, please post them in the chat as well. We'll have 5 minutes to pass these questions on. Maybe that's something that we talked about earlier, is the interoperability. If you really want to make sure that vehicles communicate with buildings and we have them integrated into a decentralized renewables energy system, they need to be able to communicate with each other and they need to be connected and interoperable. So how close are we really to that on a technical level? Maybe if Bram and Cyril, you could just say each a quick statement on that. Bram, if you want to start.
I'm sorry, I think I have another question prepared. Apologies.
I can start.
Yes, Cyril, please chime in.
Yeah. So, the say the future is already here, is just unevenly distributed. I think that the possibility to connect the charging system, so the software which is supervising the chargers, enabling people to identify the metering, the billing, the connectivity, and so on, interacting with the energy management system of the building is something that is possible today. It's easier if you take it from the same manufacturer, because then you have already all of the API and the connections that have been done, and you don't risk having contradictory orders sent to the chargers. But it's very possible. You just need to have a good cooperation between the energy management software manufacturer and the editor of the software supervising the chargers. Now, what's really important again is that you need to look at what the occupant of the building and the driver of the car want to prioritize, because at the end of the day, the energy management system calculates how much clean energy is available from the grid, from the supplier, but also on site. It calculates how much energy is stored on site, and it calculates the requirements with a flexible load. Flexible load can be managed chargers, it can be thermal storage, such as a heat pump, right? And then the energy management system has to tell the charging system you have so much energy available and it's clean. And so then it will understand what are the requirements of the building owners, what are the critical loads, how to do the balance between all of this and organize the distribution of electricity where it is needed, when it is needed. So it exists today, it's possible, it just requires some technical integration, advice to the building owner who's going to invest, and it requires a way to monetize all of this investment. Anything is possible. There is a clear question
Cyril,
with return on investment.
If you put it perfectly, the future is here, just unevenly distributed. I love that statement. How many, could you put a number to it? 1 year, 2 years, 3 years, until we manage to have it more spread out?
We have that system today that we can deliver, which we're working with a lot of EMSPs, a lot of CPOs, I mean, a lot of the players to connect our system. It's at the level of cloud APIs. It needs to be connected at the local level if you have local controller. So it's about companies like us who work both on the energy management system and on the charging point operator to connect and make this possible. So it's going to develop fast. Today, companies that have integrated can do it. And every quarter, we connect with more companies to make it available. So it's just a question of understanding what's possible, I think.
Thank you, Cyril. Bram, just one sentence to add there.
Exactly. So that's a good point that you mentioned. It's about the connectivity. What we also see with our retail energy customers is that for them, it's about the communication and the really having them on board, right? So what is helpful if you can indicate what households do have EV charging without even connectivity being in place yet. So if you can get that from consumption data, it helps to identify those loads and start interacting with customers to offer them maybe specific programs of EV rates, or for instance, some behavioral triggers that could help them shift energy while charging their car. That's sort of the starting point of a customer journey from where they can be taken on board into a more controlled, automated demand response program for EV charging.
Thank you, Bram. I have another question. I mean, as everybody's aware, we just had our the voting here in Germany last Sunday. Now the government is being formed. It's unclear who's going to be in charge, and they have very different ideas how to make a renewables future possible. Some are more regulation heavy, others want to let the market handle it. So what's your take on should the public authorities subsidize smart and V2B chargers, or simply set a minimum requirement? Björn, what do you have to say?
Well, I think the problem we see sometimes is that when you don't, when you just if you let the grid operators act as they please, what happens is you get a situation like you, for example, have in Germany, where every grid operator kind of sets their own technical way of taking control of the charging stations by kind of a centralized command and control type of approach. That is going to fail. It's not going to work. And what you see happening is it's slowing down investments in infrastructure because now we have to adapt to whatever the local grid operator chooses to use for a load control approach. So it's very clear that we should avoid we should learn from what happened with the smart meters rolled out. Of course, we know that in Germany it hasn't gone so well, but countries like Italy has done 100%. And we have to ask ourselves, is this really a question of getting the smart charger there, or is it more of a question of actually incentivizing smart charging? And the question number two is actually that incentive for smart charging already strong enough? And the answer is actually, most cases, yes. Because you avoid grid reinforcements, you let more people charge if it's a shared parking. The problem, of course, is that tariffs, energy tariffs, most people in Europe are not on variable prices, so they're not exposed to the variable value of electricity. And if you do, I've actually done this myself, just looking at the hourly prices of last year. A normal German citizen would save about 120 euros per year if he's only charging when electricity is cheaper. So then, does he need a subsidy to get a smart charger? I would say very clearly not. But he does need to have an energy contract and an energy utility service provider that actually surfaces that value to them and doesn't pocket the whole difference.
Thanks a lot. Stefan, just one quick sentence from you to add to that. Stefan, are you with us? Yes. Just unmute the microphone. You're still on mute, Stefan?
Yeah, sorry.
Perfect.
Yeah, sorry,
yeah.
I wasn't able to unmute. Yeah, I mean, just one quick sentence there. I mean, I don't think that really subsidizing the smart chargers themselves is the solution. As Björn was saying, so we believe that the policy makers should incentivize the smart charging as a full system once again. So, and here it goes with really making the promotion on the smart charging benefits, making sure that we put at the end of the day the consumer and the building owner in the center of the decision, because at the end of the day the adoption will go through them. So if we are able to deliver something smart, reliable, cost efficient, with really an impact on the CO2 footprint reduction, I mean, this is where I think the policymakers should focus, and then all the technology will follow. We have the technology, so
no piecemeal focus on the whole system as such, and specifically incentivize either the end consumer or building owners to adopt that system. Stefan, maybe just a quick sentence. Is the market already asking for smart and V2B charging solutions in buildings? So how big is the demand currently?
Yeah, I mean, you asked two questions actually. You speak about smart charging and V2B. Let's say that these are two different things, even if they are qualified under smart. The V2B is still something that is not completely requested by the market, right? We have the technology, it works. Everybody here around this table has pilots everywhere in the world, so we have some. With integration with microgrids, with BMS, with again this full system approach. I would say that today the market is requesting, and we can deliver the V1B already, the monodirectional smart charging, that bring already a lot of benefits to the building electrical distribution, but also to the grid, right? So we have already a lot of things. In the white paper I was discussing, I was explaining just before, we've made a very detailed study taking 4 types of charging. So the first one is the uncontrolled charging, so you charge anytime, anywhere. The second one is with a smart charging with static load management. The third one is with dynamic load management. The fourth one is with bidirectional. And you'll see that actually when you start to have a smart charging with dynamic load management, taking into account self-consumption, taking into account dynamic tariffs. So, and you compare that with the bidirectional, the gain is very, very small. And the problem with bidirectional is you still need to have a huge investment to make it work, right? So it's not yet completely mature. So we need to be careful that when we reintegrate the upfront capex to make this bidirectionality
so depending on which technology you look at, whether it's smart charging or whether it's bidirectional charging, there's different demands at the moment, different market developments. Cyril was nodding the head a little bit. Unfortunately, we don't have time to go into a detailed discussion here, Cyril. But I want to just throw in a question I saw in the chat because it's the exact same question I plan to ask as well. And Rolf Riemenschneider asked that. The system integration of charging poles is a real headache for housing companies and other facility management companies. What are the standards to link charging stations to building automation legacy like KNX, Barnet, etc.? And if I may add, do we need an international standard, one here in Europe or even with a bigger scope? Björn, what would you have to say, or Cyril?
I think this really boils down to, I mean, the standards work takes a lot of time. We don't have a lot of time. We need to get a lot of chargers faster. In building in MUDs and things like that, it's for sure important to be able to sometimes you can get more power out of the grid connection if you can dynamically balance with the building. Actually, you don't need to have direct communication between those two systems to make that work, because we can, with our chargers, just sense what's going on in the building and adapt the charging to whatever is left after the building has what it needs. So I would say that's not necessarily where I would focus.
Mm-hmm. Okay, so you say in regards to pace, let's not focus on the standard so much, because otherwise we will just miss out on the fast pace.
I would say, I didn't exactly mean that, but I also think that, as I mentioned before, what you see is now grid operators coming up and choosing their own kind of central command control type of solution for demand control. Please avoid that and take more of a market-based approach where you actually surface the value of smart charging.
Quick statement, Cyril, before we close the panel. Yes.
That's exactly what I wanted to come back to. I second every single word of what Bjorn said. What we need to prevent grid operators from taking control of the flexibility, because at the end of the day, if you want to incentivize deployment, you need ROI. If you want an ROI, you need a tight connection with the energy supplier, and we need the energy supplier to have flexible tariff and to monetize the flexibility coming from the installation. So what you need is make sure that the European Union continues the great job they've been doing by making sure that grid codes across Europe are deployed consistently, and that grid codes cannot allow operators to take control of the investment without proper compensation. That's the most important.
Thank you, Cyril. With regards to time, unfortunately, I have to wrap it up here. So this really was a fast-paced round with some representatives from the industry and from companies out there making all of this literally possible. So thanks a lot, Bram, Cyril, Björn, and Stefan for joining us on this fast-paced ride. It's been a pleasure to have you with us.
You should take control of the rollout of charging infrastructure. Get it on time.
Yes, then it would be done on time. Perfect. Thank you. Yes, I will pass on to Michael now. And before I do that, once again, it's been a pleasure to be here on board as on behalf of Power to Drive Europe. The Power to Drive Europe is happening in October 6th to 8th in Munich. So just in a couple of weeks, in 2 weeks around about. If you actually want to be part of it and physically meet some people and dive into it, just send an email to the organizers of this event. They will pass it on to my team and we can make some free tickets possible for you. So if you want to go to Power to Drive Europe as part of the smartEn Restart on the 6th of October, just send us an email and we'll get you in there for free. Well, it's been a pleasure. And I'm very much looking forward now to hear what actually our policymakers have to say and what their current status quo is on this topic. And with that, I'll pass on to Michael.
Thanks a lot, Zach, and thanks a lot to all the business speakers in the previous panels. Very insightful. In particular, the live demonstration tours of smart and bidirectional charger in buildings. And now, indeed, we close with this final session of our event with a panel interview with two policymakers to conclude indeed with the regulation that should indeed boost for this flexible charging of electric vehicles in buildings. And for this, we have two distinguished representatives, one from the European Parliament, who is indeed Cirian Cuffe, is a member of the European Parliament from Ireland, part of the Green Group, is member of the Industry and Energy Committee, but also of the Transport Committee. So he's really the perfect speaker from the European Parliament to discuss with us on EV charging in buildings. And then we have another distinguished speaker, is Tatu Pahkala, senior advisor to the Finnish Ministry of Economic Affairs and Employment. So indeed, a Finnish and Irish that policymakers that indeed contribute to this European tour de table from different perspectives, always looking at EVs in buildings. So I would like, thanks a lot for accepting our invitation, Cirian and Tatu. It's a pleasure to have you here. And indeed, in the next 30 minutes, or a bit less than 30 minutes, I would like indeed to have an exchange with you on different elements, indeed to advance smart, intelligent charging in buildings and the reason behind that. But before going that, I would indeed have your assessment of the big package that the European Commission issued few months ago on the 14th of July, the so-called Fit for 55 package. In there are already some provisions on e-mobility and buildings. What's your preliminary assessment of this broad package? Cirian, maybe let's start with you.
And I assume that you can hear me there. Well, look, there was huge enthusiasm, certainly from the Green Group, for the Fit for 55 package that was released over the summer. We've seen 13 out of the 16 draft pieces of legislation. In this mandate, in this 5-year period within the European Parliament, climate action is taking a central role, and despite the challenges of COVID, I think we remain on track with climate action as a central focus. My concern, though, is I fear that some of the more progressive elements of these packages will be watered down as we move them through the parliamentary cycle over the next 2 years and into trialogues and final decisions. On the face of it, there are grounds for a lot of optimism. We have the Alternative Fuels Infrastructure Directive, we have the Energy Performance in Buildings Directive, and we have other pieces of legislation there that could really deliver on a lot of what you've been speaking about over the last hour. So, in summary, the initial assessment is very positive, but I do fear that a lot of the measures will be watered down. For instance, you can see the big debate about gas at the moment. And some people, such as the Commissioner, Frans Timmermans, is saying we need to move much more quickly towards renewables. However, others are saying, I told you so, we can't move too quickly on this, we have to be careful, we have to keep fossil fuels for longer. So there is this creative tension in the Parliament at the moment. We'll see how that pans out over the coming years. But I do know at a local level, there is enthusiasm and there is a wish for these new laws to be in place so that developers of building projects have clarity on charging infrastructure in the new buildings, so that those in charge of transport and energy infrastructure have clarity on what to do in the planning of future infrastructure. So the sooner we have these laws, the better, and the sooner the political groups come to agreement, the easier it will be for providers such as yourselves to put in place the infrastructure that we provide. Thank you.
Thanks, Cirian. And what's the opinion indeed of Tatu on this? Indeed, we are approaching the co-decision process. So Cirian has some concerns. What's your assessment, Tatu, of this Fit for 55 package?
Yes, thanks. And thank you, Cirian, also for the introduction, because mostly we can agree on that. So in general, the goal of the package is very good. So to reduce the climate impact of our actions. And that is, of course, very well in line with what we are trying to do here in Finland. So the goal of our government is to be carbon neutral by 2035, which is rather ambitious. And I think that's the most ambitious goal in Europe. So overall, the kind of goal is the same here. We do have some issues with the details there. The biggest ones are in renewables directive, we would have liked to see that only the target would have been opened, as we just went through a very exhausting discussions on the renewables directive, and we are now implementing it, and we are now opening that again. So there's only a few years in between. So we would have liked to only see the opening of the target. And then in the energy efficiency, the climate neutrality basically means a very strong focus on electrification of everything, basically all the industrial processes and such, which means that we might even increase our energy use, the primary energy use, as we use, for example, hydrogen. So the production of hydrogen with electricity requires 3 times the primary energy than just using electricity directly. So that might turn out to be a bit counterproductive to kind of lower the overall energy consumption, or being just like not looking at what we are achieving with what we use the energy, but only looking at the exact figure there in the primary energy consumption. So those are kind of the biggest concerns in our side. There are, of course, many other details, but yes.
Yeah. Thanks, Tatu. And indeed, I would follow this line of argumentation and indeed focus our attention on direct electrification, and indeed the relevant to also have a flexible demand in light of this expected growth in electricity. Why? Because, for example, an electric vehicle is expected to double the amount of electricity used by a residential property. The electrification of heating in buildings can treble the electricity consumption. So the scale of the expected growth in electricity demand could put significant stress on the local distribution grid if the increased electrification of buildings and transport is not flexible ready. So indeed, my question is whether you agree on the importance to promote demand-side flexibility to ensure the system can cope with the increased electrification of buildings and transport sectors at the same time. What's your opinion?
So should I go first now? I fully agree. I'm an electricity market and network specialist here in the ministry, and I fully agree that the flexibility is the key when you install new or put new consumption sites in the electricity system. We need to have them flexible by default. So that's basically kind of no regret thing to do. In our case, we are in a lucky situation that we have quite a lot of electricity heating in Finland, which means that the networks are rather robust here. So based on our analysis, our networks will probably cope quite well with the increased loading in the distribution systems. But of course, there will be places where there are congestions, and then the flexibility is good to be there. And also it helps, well, it has multiple benefits. It can help the buildings themselves, so they don't have to increase the connection to the grid. That's one. Then also the grid might benefit, so they don't need to reinforce the network or the components there. And third, it can be used for the markets, and system benefits are there as well. So basically, as I said, it's a no regret thing to do.
Yeah, from my background, I'm trained as an architect and as an urban planner. So I often look at these issues through the lens of my professional background. You know, let me just tell you a story. I was in a friend's house recently, a new house, and he had built it to an A energy rating, a passive house standard. So a lot of insulation, very, very tightly sealed, a very well built house. He had photovoltaic panels on the roof. He had his Volkswagen i4, I think, right beside the house, and he had a battery pack in the garage as well. And he was wonderfully managing the demand between his vehicle, his battery pack, his building, and it's working really well for him. So I think what will help others to follow the same journey will be a lot more smart systems, so that the grid will tell him, will vary the price to be paid, and he can decide when to use appliances. Also, obviously, bringing down the price of EVs will help. All these new technologies we've seen during the pandemic will also help. The fact that we're talking virtually today, so e-working, I guess that's my background as a planner. We actually don't have to travel as much, and I think travel demand reduction is an important factor in all of this. But we do need smart systems to talk and communicate with each other. We do need tariffs that put the consumer or the prosumer in charge. And I think a lot of these issues will be discussed in the detail of these Fit for 55 files. And we also need education. The consumer needs to know how all of these new technologies will work together. And we need upskilling of those who will be supplying, fitting, and managing these new technologies. So we need the legislative framework, but there is a huge amount of upskilling required so that these new technologies can be managed, installed, managed, and maintained. So it is a really interesting moment. It is a watershed moment as we move from one type of technology to another. I think there will be some dead ends. I mean, as we innovate, some stuff will work out really well. Some stuff will not work out that well. And when we look at the technologies and the issues, you know, the demand management, the peak shifting, we will need those issues. We will need infrastructure reinforcement. We'll need a lot of grid reinforcement. We will need the European supergrid to get the renewables from where they're produced to where they're needed. So there's a whole menu of technologies and approaches that we need, and we need all of them yesterday, really. The sense of urgency is hugely important in this. And to get that momentum, I think we do need to communicate that urgency. And to me, that is one of the biggest challenges at the moment, is to convey that sense of urgency to everyone who can play a part in the delivery.
Thanks a lot. And I totally agree with this sense of urgency, in particular for the implementation of the electricity market design that set the rules to allow indeed the demand side resources to participate to the different electricity markets and to valorize these flexible interaction of all end users. But still, we see a lot of delays in the implementation of this framework. So this is the first step to indeed allow to go in that direction and to have indeed an active participation of end users to the clean energy transition. But indeed, we indeed discuss about, now we are mentioning the electricity market design. We talked about the Fit for 55 package already presented, but in December, the Commission should indeed revise the energy performance of building directive that Paula Pinho, the director of DG Energy, mentioned in her keynote speech. In the current EPBD directive, there are some e-mobility provisions, but they are very weak and do not feature any smart functionalities for EV chargers in buildings. So we risk that with the current directive, only dumb chargers will be installed in our homes, in our offices, creating a stress to the system because of the reasons that we were discussing before. So do you think that the revised EPBD could be the opportunity to overcome this stalemate and fill this gap? Sharon, maybe if you want to start also based on your experience on
no,
the EPBD files.
Yeah, I absolutely agree. And as a member of both the TRAN and the ITRI committees of the Parliament, the topic of smart charging is central to my work. And I'm currently the shadow rapporteur for the implementation report of the EPBD in TRAN. And in that report, I am calling for the need to deploy charging infrastructure capable of smart charging across the member states. So that means greater investment in e-mobility and vehicle batteries. And the benefit to increasing our investments in e-mobility is that it will facilitate peak shifting and demand response, creating cheaper and efficient electricity grids that require less generation capacity and infrastructure. So I think the EPBD revision is an opportunity to ensure that our buildings are future-proof. So we have to break away from silo thinking by integrating e-mobility alongside our buildings, especially during periods of renovation. And we can see the growth in sales of both electric vehicles, but also electric bikes in recent years. And with those building renovations, we can encourage the uptake by providing both adequate parking space and perhaps e-vehicle priority and the charging infrastructure. I mean, the right to plug is an issue that has come up in recent time. And the EPBD is really the only EU legislation to address private charging. So we really have to ensure that that's in there as part of the EPBD revision. The Alternative Fuels Infrastructure Directive, I'm a bit worried that that will be watered down with the different colors of hydrogen and also LNG and CNG. It's also rather blunt at the moment with e-charging every 60 kilometers. So clearly that has to be refined to reflect population densities and to focus in on new development areas and areas where buildings are being renovated. But it needs to be done in a careful way also. We need to make sure that we don't have charging points that obstruct pedestrians, for instance. This is an issue in our cities and towns at the moment. So this integration, not just integration with the grid, but integration with the built environment, with the public realm, is a crucial issue. And we can look at aspects of this, such as delivery and logistics. The last mile delivery can be electrified quite easily. So there are particular hotspots where maybe we need to focus resources in the early part, certainly in the next 5 years. Cities are leading the way on some of the innovation and rollout, as are logistic firms like DHL and others. So I think there needs to be a good rapport with private companies on their innovative approaches. And if we do this right, we can really achieve a real shift to electrification and avoid too much demand on the grid. Thanks.
Thanks, Sharon. And Tatu, what's your opinion on that?
Yes, again, it's easy to follow Cirian here. So basically, this is the perfect moment to assess if such requirement is necessary. I'm personally not a big fan of the regulatory approach here, as the markets seem to deliver at the moment, at least here in Finland, appropriate charging. But so kind of it's a delicate balance if we need even, but there might be some clarifications also beneficial for this.
And But do you agree that indeed that we need to have a charging infrastructure that is intelligent, future-proof, and does not lock into one technology? Otherwise, indeed, this would create a stress. And as we have seen in the virtual tour in the previous sessions, we have both unidirectional and bidirectional technologies already on the market. We need indeed to have a framework for Europe to enable them to be indeed deployed. Do you agree on that, sir? What's your opinion?
If I go first now, for example, the uni or bidirectional thing, if we look at it from the system perspective, it's not that big of an issue. So the smartness is the key. So if you can kind of time the recharging operations to those times that the system that are beneficial to the system, I think that's plenty good already. And then comes the bi-directional thing. And we also have to remember what the customer wants. They might not be very comfortable with their vehicle used for the system needs, but of course they can opt in if they want. But we need to keep in mind that it is indeed it's the customer's load what we are, or customer's cars that we are talking about.
Yeah, I want to agree with Tatu on this. I think the customer is very important. I mean, often we just end up having a policy wonk discussion, but ultimately the end user wants a simple dashboard with simple choices that allows them to save money. And, you know, I fall into that hole as well as a legislator, because I look at, you know, that simple cartoon of a vehicle, a building, a battery, and the end user. And I think the alternative fuels infrastructure, the energy performance in buildings directive, the battery regulation, the 10E and 10E package. And before you know it, there's about 6 separate pieces of legislation. But a bit like Steve Jobs and the iPhone, he didn't really invent anything new. He just put a really good front end on the technology. So I guess my role as a legislator is to not only produce good functional pieces of legislation, but to deal with the horizontality of the connections between the 16 elements of the Fit for 55 package. And I heard Franz Timmermans say this in Strasbourg 2 weeks ago. We really need to keep a good eye on the contradictions and the synergies between the different pieces of legislation. And if there's anything keeping me up at night, it's probably the challenge of how to make all of this work together seamlessly, from bidirectional charging to the end user saying, look, I just want to renovate my home and save money. I need to think about a new boiler. Will it be gas? Will it be a heat pump? And wouldn't it be great if I could just plug in my scooter or my car to the building? We need to make these choices really simple and really easy. And there's a role there for the EU, but also for national governments and local authorities and, you know, municipalities to make this stuff work simply and easily for the end user.
Thanks a lot. Indeed, I fully agree on this challenge of horizontality and also a consumer-centric approach. Because if we don't have in mind that at the end users should be the beneficiary of this, we are missing a relevant point. And indeed, the clean energy transition requires some transformative changes, including behavioral changes. And in particular, if we are thinking indeed about smart charging of an electric vehicles, this will require also a change from the status quo. Now, we are immediately fueling our vehicles, while instead a smart charging of an electric vehicles would require a longer duration process to do that. Do you see it as a challenge, or are Europeans citizens ready to adapt to this evolution? Who wants to start? Sharon, maybe as a representative of European citizens, it would be very good.
I think there is a huge communications challenge. I think we need to bring people with us on this journey. And, you know, very simply, people know we need to do something. They not only see the floods and the wildfires on their TVs or on their smart screen, they can see this link between emissions and extreme weather events, and they can see the IPCC reports. But ultimately, as consumers, we want to be given easy choices to make that behavioral change. You know, that those books about nudging, Cass Sunstein, of how do you make the default action better and better for the planet and easier to make as a choice. So that hangs over me quite a bit, of how do you make the easy option the climate friendly or the low emissions option. And at the moment we've a long way to go, because certainly in my country, you can buy a regular car for 15,000, 20,000 euro. An electric car is going to be 25,000, 30,000 euro. So the vast bulk of people will take the easy option and go for the petrol or diesel vehicle. And we've the same issue with modal shift of trying to move people where possible out of cars onto public transport, onto walking and cycling. So we need to make those kind of choices easier. And I think from my limited experience of how we move to electrification, we're still in the early stage of making these choices easier. I mean, what is helping is if people drive an e-vehicle, or the friend buys one down the road and brings them out for a ride, and they can see how wonderful they are. So it's working at the manufacturer end, but then it's all about linking in the charging facility with the existing built environment and with the type of services that the municipality might offer, of ensuring that it's easy to charge and that the electricity, the utility provider makes it easier as well and provides you with a series of options for different tariffs on when and how you charge. So we've talked a little bit about utilities, but there's also a role for utility regulators to look at the massive changes that are required, and to help the consumer make the easy choice. So there's a regulator issue there as well. So communications are at the heart of this, allowing people to make the greener choice more easily is the simple way of doing this, but that requires a lot of work behind the dashboard to give the consumer these easy choices.
Thanks. And this, I think, is the perfect transition to a final remark from Tatu.
Yes, thanks. Very easy to be on the same side as Cirian here again. Easy, basically, easy should be the default choice, and the easy should be low emission and low cost as well. What I want to highlight is the role of service providers. They are the key link between the electricity markets and the customer and the EV charging. So they should make it as easy and simple as possible for the customers to be flexible and low emission. And I think already the current regulatory framework allows that. So it's not about regulation, it's only about implementation and actually providing customers with such services that are easy to use.
Thanks a lot to both of you for this conversation on different elements related to indeed the regulatory framework, but not only. We touched different elements. So thanks both to Cirian and Tatu for your participation. And I would like indeed to conclude today's conference, Unleashing the Value of Smart Charging in Buildings. We started indeed with the keynote speech by Paula Pinho, a director of European Commission, providing a framework of the legislative framework on the table and upcoming. We had some live tour demonstrations on really what is possible now on how to charge unidirectionally and bidirectionally our vehicles in buildings, whether they are commercial or residential. And then we had a conversation with different business representatives on the broader picture, on the benefit from the consumers and also the systems. And we concluded with a conversation with a member of the European Parliament and the representative from a member state. So we hope that it was insightful, this conference today. We are going to keep working on making electric vehicles, decentralized energy resources that are flexible, along with all the other decentralized energy systems, to integrate more valuable renewable in the systems and to make sure that the clean energy transition is a successful experience for all. Thanks a lot and have a good continuation of the day. Bye-bye. Thank you.